you can think of voids as preserved pockets for our universe. And knowing more about dark energy will tell us what is the destiny of our universe.
So, what is a cosmic void?
As the name says, one will tend to think that cosmic voids are empty. Cosmic voids are not really empty. It's like less crowded areas of our universe, if you see what I mean. And what is absolutely amazing is that these are, in fact, the largest regions of our universe. And it's only with the last few decades where we can actually build huge maps of the galaxy distribution. And in these maps, we can find those regions with fewer galaxies that are known as cosmic voids.
Can you kind of put it in a perspective that somebody like me would understand? Like, okay,
Mhm.
it's an empty space. Like, I get it, but in my mind, I can't kind of quantify how empty the universe or full the universe would be.
Voids are of sizes of tens to hundreds of megaparsec. And because this doesn't really, speak to us, I'll try to give a bit of an idea. We know that light takes time to reach us. For example, the light from the sun was emitted 8 minutes ago and is just reaching us now. So it takes 8 minutes to go all the way from the sun up to us. And if we were to, think of the time that it will take for light to cross voids, it will basically be of the order of 300 million light years. So, it's really huge distances. And over those distances, we may have, maybe 100 galaxies or something like this. So those are extremely isolated galaxies that live in very quiet spaces of our universe.
I feel like this question is going to make no sense. So bear with me a little bit, right? But if we go from the Big Bang, which everything was kind of condensed into one area, and then it expanded, and the voids formed as the universe expanded, are the galaxies in those voids made of something different? Like, why would that area not have stuff in it? Like, is there something different about the mass or whatever that wouldn't have kept things close to it? Does that make any sense?
So generically, it's a very today question because nowadays, because we finally have access to voids, we're trying to understand whether the properties of galaxies inside underdense regions are very different from the properties of galaxies in overdense regions. So it's more the other way around, right? We are finally accessing those voids. We can look at those galaxies with very deep surveys, and then we're trying to understand whether they're different or not. One thing that seems, consensus is that galaxies in voids have a somewhat lower mass. But all these studies are, just starting because void cosmology and even the study of galaxy evolution for void galaxies is something that it's relatively recent, I would say, in the field.
Okay. Even though you basically said, like, we're still figuring out, I'm going to ask the question that probably doesn't have the answer. But why would they have less mass? Like,
Well, in some sense, for example, you can think if I'm a galaxy and I'm sitting in a region where I'm not finding other galaxies, things like mergers of galaxies, which is when you have pure galaxies that become one galaxy, are going to become more rare. So this is the one example of things that could have an impact. Generically, in regions that are known as voids, there is also less matter. And as a matter of fact, matter, and more precisely dark matter, is the seed for galaxies. So if you have less matter, it's also less likely that you have, extremely massive galaxies.
there was something, and then it just kind of snowballed over billions and billions of years. Like, there was something different about them, and then they just didn't evolve the same way that other places did.
Yeah, it's because they were in underdense regions. So the initial perturbation of our universe indicated regions where we had a little bit more matter and a little bit less matter. And this tiny difference that we already see in the primordial universe leads to the formation of structures that we see nowadays.
Does space behave differently in these areas?
The question really depends on whether you ask it locally for us or on a very large scale. So, from a human perspective, my answer is no, because as a matter of fact, whether I'm on a galaxy that is sitting on a void or on a galaxy that is inside a cluster, for me, I mean, I'm on a planet, I'm going to feel the planet's gravity and that's it, right? So it's not going to make any difference for me as a person. However, on cosmological scales, things might be very different. For example, galaxies that live inside voids, they will, for example, interact less with other galaxies because they never meet other galaxies in those, under dense regions. And so there are fewer things such as mergers of galaxies and all these complicated effects that astrophysicists try to model. So in some way, you can think of voids as preserved pockets for our universe, regions where very little happened on cosmological scales. And this is precisely the reason why they are easy to model because we don't have a lot of complicated effects. We don't have nonlinearities. We don't have things that will, make our theory more complicated.
What can we learn from the voids that we couldn't learn from studying the clusters?
This is an awesome question. Thanks a lot for asking it. So basically, the idea is that we know that our universe is expanding, and this is already super surprising. But what is even more exciting is that a few decades ago, observations started to indicate that the acceleration, the expansion of our universe was accelerating. So not only our universe is becoming larger, and that's already interesting and surprising, but this is happening faster and faster. So our universe is becoming larger and larger, and this is happening at an accelerated rate. And we don't know why. So because we don't know why, we basically believe there may be a component that is called dark energy, which, we really don't understand. And so we say, okay, maybe this component, this dark energy, can be responsible for the acceleration of the expansion of our universe. So taking, the galaxies in the universe, because the universe is expanding, they're being pulled away one from the other. So the universe is becoming larger and larger. And responsible for this will be dark energy. Now, why are voids interesting in this respect? Because by definition, voids are regions where we have very little matter. And if there is one thing that we believe dark energy is that it's not matter. So in some sense, voids are dominated by this component. We know that voids are going to be dominated by dark energy. So if we want to understand why our universe is accelerating its expansion, we need to look into those regions where there is very little matter so that the signal from dark energy can be captured nicely. So those are the regions where we expect to have answers about the most crucial, questions in cosmology nowadays.